This rocket here is awesome. And the question is, why would you design it this way? Okay, so what should a rocket look like? So we know, say I draw a rocket, looks something like this. So first we know the center pressure, the point where the air pushes on it, should be behind the center of gravity. So if the rocket's traveling this way, we want the center pressure behind it. So if it kicks out like this and it's moving up, the wind pressure will push down more on the back end and it'll right itself. So what else would we like? So we have a motor in here and it's spewing our ejection so that we have our thrust forward. So imagine that some of this energy is not straight down, some of it's going sideways. Well, the distance between where the motor is and the center of gravity, so let's call that D. If we have some force going this way, we have a torque, right? D times whatever force this is. So if we minimize this distance, i.e. we move the motor such that it's pushing out right at the CG, so I have my rocket, say the motor's right in the middle and the CG is right here and the CP is right here, then any non-downward force that goes out sideways would actually not change the direction of the rocket. So that's desirable. So when I did my rocket, I pushed the motor up higher than you would expect. Typically you'd see the motor way at the end. I didn't want to do that because then I'm getting rid of the torque from non-ideal exhaust direction. And also, as you'll see, the rocket spins a little bit, and that also helps to average out any sideways thrust. So the first thing I did is I actually had the batteries in my rocket are below where the motor is. And what I'm doing there is kind of moving some mass down, as I'm trying to put the CG right toward, as close as possible to where the exhaust is. Second thing, we need stability. So how do we do that? Stability. The spin keeps it going in the same direction. Once the spin dies, you lose stability. Okay, the big question is, how much spin do you need to keep something straight? Seems simple, but it's difficult. I did some experiments where I spun a motor at an angle and figured out how fast this would have to go such that it wouldn't tilt, hanging at different points. Basically, what I found is there's a certain amount of angular momentum that'll offset a certain torque. So let me show those equations.
Okay, so the inertia of something, this is somewhat like mass, but it's a resistance to angular change. The inertia of a spinning disk is basically 1/2 mr squared, so more mass, more inertia. The bigger it is, r is the radius, the more inertia. And your angular momentum is your inertia times basically the spin rate. So inertia times 2 times pi times f, so if something's going 60 cycles per second, f is 60. If it's 60 RPM, f is 1. So this is angular momentum, and that's a measure of how much energy something has in its angular rotation. Now we talked about torque, which is just basically F times D. And so, the bigger rocket engine, rocket motor you have, the more force you would have, and D is how far away from the center of mass your rocket is placed. What I found is basically L, your angular momentum, has to be about 1.6 times the magnitude of torque. This is just based on doing some experiments. So this is in SI units. If you use kilograms, meters, newtons, and meters, then this is the equation I came up with. My motor spins at 6,000 RPM. My mass is about 68 grams. And so from there, you can figure out how much angular momentum I have, how much torque I should be able to offset. Okay, so showing the rocket again. So you can see I put the motor way up there, the battery's below, then I tried to put as much mass as I could as low as possible, so I have a Raspberry Pi and DC regulator. I'll go through all the schematic in a future video. IMU, some stuff to control the regulator. There's to be a digital potentiometer. And then there's a spin mass. I'll show you in the CAD that I try to put as much mass as I can towards the edges. And I try to make this thing as low as possible. This is like as physically as low as I could go. And then up here I have a charge for to blow the black powder ejection charge, and also the string that this thing will be hanging from. So this will be encapsulated in here, which goes on there and then screws in, and then we'll call the nose cone we made, which is tied in. So I have a video where I blow it off as well. So I'm SSH'd into the Raspberry Pi, I fire it up, give it a second, and our little stability mass should start going. There it goes. So I'm just demonstrating the speed there. Anyway, pretty cool, but that's how I'm looking at stability right now. Then here's what I have for CAD. So pretty much every single piece that I 3D printed is here. So this is just using the free CAD tool again. So here's the spin mass. I didn't model the DC motor here. Let's see. So the nose cone we talked about. Inside this guy, it basically holds the black powder ejection charge, and then this is just a tie off for the rope. So when I blow the nose cone off, it's attached to the parachute. The parachute shoots up. Standard high power rocketry stuff there. Here's the mount for the rocket engine. So sometimes I say motor, and I mean DC motor for the spin mass or the rocket motor for the thrust. It's kind of ambiguous. And then a few mounts for the electronics. This is where the Raspberry Pi mounts, and then this is where the batteries are all held. And then the fins. But so pretty easy to CAD all this stuff up, and then 3D print it all and put it together as you saw. This kind of describes why I built it this way. Kind of cool, huh? Most people build the rocket inside the tube. I did it with 3D printing and with these little wood bars. I thought it'd be lighter, more easily accessible for screwing with the electronics. Not sure it's lighter, so we'll see. Runs on these ST's E9 engine, and I'm gonna have to jam way up there. Hopefully leaving it about the center mass. I still gotta measure that to see where the center of gravity is. Hopefully it's right about here, in which case, you know, the sideways torque from this motor won't have any effect. But there it is. I use rocket epoxy all over the place. I love it. Use it even around the house.